Hello, everyone. Welcome to AMT's Tech Trends podcast, where we discuss the latest manufacturing technology, research, and news. I am Benjamin Moses, the Director of Technology, and I'm here with
Stephen Lamarca, Manufacturing Technology Analyst.
Steve. Welcome to 22.
It's a new year.
It's a new year.
And I just used my old title. It hasn't changed much. Just Technology Analyst. I just felt I didn't think to remove the manufacturing part.
That's all right. Everything's a little hazy.
I love
this time
manufacturing.
Just keep it in with good to get a tattoo. I love manufacturing. All right. We passed holidays. A lot of people got gifts.
Heck yeah, dude.
Got anything good?
Dude, got a lot of great Christmas presents.
Oh, yeah?
Man, what are some of my favorites? For one, this sweater that's keeping me warm in this cold office that the heat is actually on full blast right now.
Yep.
Which is why it's so stuffy and why probably by noon our noses are caked and really dried out. Yet it's still only like 70 degrees in the office.
That's a bit chilly. Because
this floor has like no insulation whatsoever. Water comes in when it rains. Birds nest in here. If like last year we had the 17-year-old cicada thing. Cicadas were in the office.
Did you have cicadas here?
You didn't see that?
I don't remember.
We were still in like not lockdown.
Yeah,
but,
we're still
but office was optional.
Yeah.
There were cicadas in here. I remember when we were shooting the IMTS YouTube series.
Yeah,
there were cicadas in here.
That's fine.
Anyway, other things I got for Christmas. You know you're an adult when you're excited about a herringbone pattern end grain teak cutting board. Inch and a half thick, baby.
Oh, that's nice.
Nice cutting board. Now I just got to get my knives sharpened. Because I'm marring the hell out of it.
And you got to take care of it.
Yeah, I got this board cream.
Okay.
Which is just beeswax and mineral oil.
Cool. That
I have to rub the cutting board. Like it says like once a month.
That's a lot of maintenance for a cutting board.
It is a lot of maintenance, but you don't want them smelly. You don't want them warping.
I just put mine in the dishwasher, which you're not supposed to do at all. That's why I shifted.
You're killing me then. What else did I get? Dude, in the apartment, I'm going to try to not to spend too much time on this one.
All right.
In the apartment, upgraded the bathrooms because we got 2 bathrooms.
Yep.
Upgraded the bathrooms to having bidets.
Congratulations.
Bro.
Life-changing?
Life-changing. You know, like when, let's say you're rolling out of bed a little late.
Sure.
And you go have some breakfast.
Right.
You brush your teeth. And then you have to sit down a little bit to wait for your morning to start, if you know what I'm saying.
Sure.
And you find out it's like 15 minutes later and it's like, dude, come on, we got to get moving. So you get fed up waiting and you just hop in the shower. And then you get out of the shower and then it's like, oh, now you're ready.
Of course.
With a bidet, that's not a problem anymore. Because, before having a bidet, you got to, if you got out of the shower and then you had to go, you may as well get back in bed and start over.
It's a long process, I
guess.
guess.
With a bidet, baby.
22 is looking good with a bidet, I guess.
What else? Got a new SSD for the gaming computer.
Nice.
Not necessarily a new one, an additional one.
Yeah.
To double my storage capacity. Why am I forgetting the last one? There was another one I want. What'd you get? What'd you get?
Well,
I'll try to come up with it.
I feel bad for the people that try and get me gifts because I buy whatever I want through the year. I don't wait to get something I'm interested in. And plus most of my hobbies are unique enough. It's hard for someone to buy me gifts.
Mm-hmm. I get in a lot of trouble for that as well.
Yeah. So I just buy whatever I want throughout the year. So most past couple of Christmases, it's been a lot of old man gifts.
Mm-hmm.
I get a lot of socks, a lot of ties. I got a couple of like random utility tools that are more comical than useful. So
right.
So the holidays for me is just a lot of spending time with the family and actually trying to figure out how to give good gifts. So I gave Amelia. So Amelia, my 7-year-old, was really interested in I guess a lot of fidget stuff now.
Right.
So for us, like the fidget spinner was like the biggest popular one that came about recently. And I guess the kids nowadays have a thing called Pop It. It's kind of like this big sheet of rubber bubbles that you pop back and forth.
No way.
So she wanted like a 100 count pop it. So it's a giant sheet of 100 bubbles on it.
Wait a minute. Like bubble wrap, but you pay for it?
So it's not a one-time use bubble. You just keep popping it back and forth.
Whoever made that should be a millionaire. That's amazing.
And then Amelia asked for a Pop It fidget spinner, so she combined both worlds.
Wow.
So that was fun. She got a lot of little fidget toys. It's interesting. She's not really fidgety, so she just kind of uses them as toys to play around in. So
yeah.
It was fun. A lot of good times.
That's awesome.
Got a couple of board games. I enjoy getting board games now. It's fun activities.
Good for you. New Year's was fun because we played some games. I had some guests over. One of them was unvaccinated and, of course, got COVID.
That's a bummer.
It is a bummer. He's all right.
That's good.
He says he's full recovered because like he's in denial about it. But every now and then we'll be playing online games, and he gets in the mic. You're like, oh, there's somebody over there. You're like, yeah, man, you've recovered.
That's
good
right.
job.
So it's gonna be a long stretch before our next holiday. So just keep that in mind.
Oh my God. No.
Let's get into some articles, man. I got a couple of good ones. I got one on cybersecurity. So, we've been talking about cybersecurity for, a couple of months, and there's a growing need in improving our security resiliency in manufacturing. So NIST did an update on engineering guidelines, cybersecurity engineering guidelines. So this is geared more towards people developing software, code, programs. And I thought it was very interesting because it cascades into the manufacturing where, if you're doing custom applications on the shop floor, or if you're building controls, or you're building, any type of software in manufacturing, right? How do you build in security or resiliency into the application or program? So it's not just looking at the infrastructure within a building to hopefully make sure it's secure, make sure your switches are secure, or you're controlling things, kind of the digital physical side of the network, but also building in security within the program itself. So I thought that was a very interesting look at, the need for, and it's a big document. It's like 200 some pages, but it definitely addressed a lot of things. And a couple of key elements from the article from NetGov. So the publication addresses engineering-driven perspective and action necessary to develop more defensible and survivable systems. Inclusive of machine, physical, and human components. So it's looking at a very broad spectrum, right? And then the second part is building trustworthy, secure systems cannot occur in a vacuum, which isolated stovepipes for cybersecure software and information technology. So again, it talks about the breadth of what they're kind of approaching. So NIST has, I guess, two core documents, right? So they've got one that looks at, hey, you're an organization. How do you assess yourself on making sure you're resilient? And then now it takes a deeper dive of, now you've got software and program that you've developed or you're developing or implementing within your facility. And then how do you make sure that that is resilient also in connection to the higher levels organization? So a fascinating look, and I'm glad that
Absolutely.
There's more direction, more information, and more guidance on, hey, we need to improve our security.
Wow. It's funny. One of my new neighbors who moved in, I want to say like not last month, like in November or October of last year. So he hasn't been living at our place long. He's from Alabama.
Uh-huh.
And he's a young kid, early 20s, from Alabama, moved in, has a brand new BMW 4 Series, brand new BMW S1000 RR motorcycle. And, we live at a really nice apartment complex.
Sure.
And we started riding together, riding the motorcycles, at least before it got way too cold. But really talented rider, too. And like, dude, what do you do? Like, how are like, is this so? Oh, and he wears like, a brand new like Rolex Date Just too. I'm like, is this mommy and daddy's money?
Sure.
Like, I'm blunt about that kind of stuff.
Right.
Or like, what do you do, man? It's like, no, from Alabama. Parents are still back in Alabama. Grew up dirt poor. But I'm working in cybersecurity.
High demand, man.
That's where it's at.
Does he have an accent?
A little bit.
Okay.
A little bit.
I do enjoy a little Alabama accent.
So definitely like a southern up and coming southern gentleman, because he's got this ever so slight accent, but he's like trying to cover it up and he's really proper and all this stuff.
Yeah.
Like, dude, moving up in the world for sure.
Nice. That's cool.
Cool dude. But cybersecurity, I think he said Booz Allen.
Okay. Nice. Well, he's also working for Booz Allen. So
yeah, they're treating him well.
Talk to me about your article. What you got?
All right. First one I got from 3D printing industry. Bond 3D achieves 99% part densities with void-free peak 3D printing technology. Peak is in polyether ether ketone, not peak as in pinnacle or the apex or the summit of a mountain.
Nicely done.
And so what's really cool about this, peak is typically printed with conventionally with FFF or material extrusion.
Right.
And they're still doing that, but Bond 3D has a pressure controlled material extrusion approach to essentially eliminate voids,
right,
and match the material density similar to that of injection molding.
Wow.
And it's really wild because we've all handled 3D printed parts before, and you see each strand of material, of course. They have, through material extrusion, which we know is like one of the most basic forms of additive manufacturing.
Right.
Like it's just laying down a line of material. Through their pressure controlled process.
Yep.
They've been able, I'm repeating myself. They've been able to achieve a material density of 99%, which is very similar, close to, if not better than, injection molded. And the coolest part was, and you'll have to see this article later, is there's a diagram, there's an image comparing a conventional 3D printed part, and there's a very close up shot of 3D printed peak, and on the left, and on the right, it's just like a solid image. It doesn't look like anything's there. It's that, and I think the scale on it is like 1 inch of the picture, and the picture's only like 4 or 5 inches wide. 1 inch on the picture is 100 micrometers. Sure. 100 microns.
Yeah.
So
that's fascinating. That's
it's really cool. Void free 3D printing is kind of a big deal.
That's kind of a big deal.
I a couple of years ago, 3D printers are already crazy expensive, especially the industrial grade ones. Sure. Some of them are really cheap, but
I mean, it depends on your perspective, I guess.
And it also depends on the process. Material extrusion, I'm confident, is typically a relatively inexpensive process, but I've always been wondering, with additive, because the machines can be really complex, and they're relatively large machines with an extremely controlled environment around the build plate. Usually, not all the time. But why haven't some of these more advanced machines, some of these like multi-million-dollar machines, in that controlled pressure and environment chamber that's almost like a clean room, why haven't they also like doubled the purpose of that room as like, a cryogenic treatment chamber or a hipping process chamber to take, what is typically a process that yields a part or object with a lot of internal voids. Sure. You double or triple the process or the capabilities of said chamber to do those processes to, improve the density and molecular composition of the part. And, one person that I ran that idea across said it's probably only a matter of time. Once people start spending more money on additive, it's probably only a matter of time before that machine comes out. And now with this, it's like, we might not need it.
Sure.
Which is pretty cool.
Yeah. And that's an interesting thought experiment that you mentioned about the controlled environment. Right. So one thing you want to keep in mind. So if you look at, if I look at the build environment, from my perspective, it's a matter of controlling the environment for like a welding process, right? So you want a clean environment. You want a, in some cases, inert atmosphere. Yeah. You could pressurize it. You probably could control the temperature a little bit to some degree. When you look at either homogenizing temperature cycles or hipping processes, then you get a matter of scale in terms of temperature and pressure. So, the pressure chamber on a hipping cycle could be, 10,000 PSI. Right. Right. I don't know if you want to build that much into, additive machine where you may not use that process every single time. So
right,
it does get into one of the articles later that we talked about. I'm going to talk about for autonomous mobile robots of single task versus multitask capability. So it's an interesting dilemma where you want to increase the capability, but the question is, you always need that capability.
Are you going to use it?
And that's not a cheap capability to incorporate. That's the thing. It's you going to a hipping oven. That's a lot of pressure and really high temperature. So for like Inconel, you're taking it up to 2,000 degrees Fahrenheit. That's a whole new scale of heating elements and temperature controls and things like that.
Right.
So it's a fairly good thought experiment, and also, I mean, those hipping cycles aren't short either. So do you want to take it out and parallel build another part while you're hipping the previous part? So now you get into production flow questions. But it's always the dilemma of, do you have several machines and continue producing it, or do you have one machine that you get a complete part out of? And that's ongoing with subtractive, with every single machine. Even back at Eden, where we discussed, we used to have 3 machines that had internal cutting, then external cutting, then like a finishing op.
Yeah.
And then we did the experiment of what happens if we just do
it all on one machine,
3 setups on one machine, right? And obviously you couldn't have one part completely done on a single setup, but you could have 3 setups on one machine. So the machine would, after the machine cycled, you'd take one part out and keep adding new parts to kind of cycle through it. And we got fairly good throughput, and it was very similar throughput compared to the 3 machines. But now we're able to kind of balance the time for the operator of loading each of the machines. So it's always going to go back and forth, I guess.
Yeah. I don't know. Maybe I just follow the auto industry too much and think that, not every soccer mom needs a V8 and 8-inch lift and all 4-wheel drive, but stuff sells.
Stuff sells. All right. So let's get into why multifunction robots will take over commercial robots. So this article from Spectrum, IEEE, they're talking about autonomous mobile robots, which is all the rage nowadays, right? So even from warehouse robots into a lot of the applications they talk about are the recent need for sanitizing, cleaning certain areas, certain rooms, particularly hospitals and things like that. And they're talking about the massive growth of AMRs across the board. So from like warehouse robots to single task robots. And that's the point of the article is talking about is the need for single task robots is dying really, really quick. So the robot that you see could be doing, inventory management, like in Walmart, going through scanning all the stock, all the shelves. What else can that robot do? And that's the core of the question: is the return on investment on these single task robots compared to adding, 2 or 3 other features. So you could incrementally add the cost to the AMR, but the flexibility and return on investment is so much higher on just adding those other features that the author feels that the trend will be, this robot could clean the floors in an manufacturing floor and pick up parts.
Right.
So there's always downtime for these robots too. So obviously there's issues of charging the battery and things like that, but there's always, when the task is done, the robot doesn't need to sit still, right? So how do we keep this robot running basically 24 hours? And the overall thought process and the direction that the field of industry will be headed to is adding incremental capabilities where it's doing one thing, but then it's part of a big organization where you want the robot to be doing several things. Something like in a hospital, you could sanitize the floors, but also transport drugs from one place to another.
Sure.
So I thought, it's a very good perspective on the kind of the trend in AMRs where single tasks are great.
Yeah, that's very thought provoking.
Yeah.
Like, I mean, especially when you brought up the retail part of like inventory. One of the things back when I worked at Total Wine that we had to do every night, we did like a mini inventory. It wasn't a full on inventory, and it wasn't even considered an inventory. But like, you look at the shelf, determine if the shelf is empty for a particular spot. Scan it. Are we actually out of stock?
Right.
And if so, put this sticker up there. And if not, then you search by like behind the shelves for a bottle or up top where the cases are. It's a real headache. But the worst part of it all was really facing I don't know if you're familiar with that, but as you're doing this process, as you're checking the aisle for product and seeing what's in stock, what's out of stock, if somebody needs to go look for it to fill the shelf back up, facing was, as customers come through the store and like if they see something they like, they grab it and put it in their cart and then go check out. You're removing product from the shelf. Facing is the annoying task of pulling product that's back in the shelf forward to the front of the shelf to make the shelf look really full and pretty.
That's fun times.
Please get like Boston Dynamics Spot to like walk down the aisles, scan inventory, but also have the robotic arm on top of Spot to face the product. Oh my God. That would allow for so much more slacking off in the break room.
The key for Total Wine employees, slacking off in the break room.
Dude, that was I kept you alive.
All right, tell me about this other additive article you got.
I have another one. This one's really fun. We've talked about this process before. Another one from 3D printing industry. They are, I love this website almost as much as phys.org, but that's a little bit more nerdy. Blackstone begins series production of lithium-ion batteries using 3D printing technology. We've talked about 3D printed batteries before. The concept is awesome. It is not new,
right?
But the best part is it's gone from an academic level. This used to be like MIT research to white paper to like heavy industry research, but just testing proof of concept. Well, the concept has been proven. And Blackstone is beginning a production line made for 3D printing battery components, if not the batteries themselves entirely. And it's awesome. I mean, it's just something really to be excited about. 3D printed batteries, especially with how additive promotes new materials design and new materials invention, almost, so to speak. That additive is opening up a whole new possibility for batteries, not just, designing physically and like the shapes of batteries, but materials wise. And so it's huge because it's gonna, when Canada's out of those raw materials for, conventional batteries, we're going to need some other forms of chemically containing electrical energy.
And I do see that is very interesting because the need for batteries, it's outrageous, right? So
it will never go away,
right? So not just looking at vehicles, right? Obviously the shift towards EVs for vehicles, but also we just talked about AMRs, right? They're going to need batteries. So the need on the manufacturing floor is significantly grown quite a bit, right? So it's the advancements in battery. I think it's crucial to a lot of our autonomous growth in the future. So that's fascinating. I'm glad to see, from research that we've been talking about to production, or hopefully production. I hope this works. To seeing something in the field where there's a thing you kind of saw grow, right? So that's super interesting. You're never going to go EV, are you? Car?
I would go hybrid.
Yeah.
EV, I don't think so. Have I shared my dumb opinion on that before? I've got nothing against EVs.
Sure.
I like EVs. Yeah. I love Tesla cars. I think they're cool. I don't have any big beef with Elon Musk. I think he's actually pretty cool. I'm not a fanboy.
Sure.
And I do have a problem with Tesla owners. Like there's some rabid Tesla owners and Tesla fanboys and Elon Musk fanboys that are a little bit extremely toxic.
Sure.
But the way I see it, everybody thinks of like EVs as being like the fastest cars out there. And, EVs are like the quartz watch of automobiles.
Sure.
And vehicles, they're superior, but gas engines are going to come back as a luxury good. And people are going to, who saw them as tools before, are going to see them as flex pieces in the future.
Sure.
So take care of your internal combustion engines, because I guarantee you a long time from now, there'll be something very special and worth cherishing. And gas will probably be cheaper then because everybody's going to have gone EV. The other thing about EVs is I don't see them as faster, superior vehicles.
Right.
I see them Well, I don't see them as like superior cars. I don't see them as fast cars. I see them as slow teleportation. It's just the
Sure.
next step in the evolution.
Sure. That's fair. That's some good skinny. I appreciate that.
Okay, good. I think it's a little bit stupid, but
Well, I wouldn't disagree with that either. The last article I got, Steve, is 5 mistakes robotics startups should avoid. So
ooh,
startups are plenty nowadays. A lot of people are getting into physical automation.
deliver your product on time.
That could be one of them. You talking about mistakes?
Yeah, your first mistake, not delivering your product on time.
Not meeting your commitment.
If somebody gives you money,
Yeah.
you have to give them a product.
That's fair. So, this article is very focused on the companies that's a startup, but I think it makes sense from the other perspective too. If you're working for a startup, these are things that you need to keep an eye out for. I mean, as you're importing new technology and working with new suppliers and customers, there could be a lot of smart people, but there's some fairly common mistakes that these article talks about, and I think it's true for any technology development. If you're doing something internally too, I think these are fair applications. So a couple of the bullet points is developing software in a bubble. So obviously they've got some human to machine interface and developing the software outside the context of what else is the operator doing. The interaction between humans and machines is fairly important. So I think that's a fairly good look at a key element of software development is, just put in context the rest of the environment around you. Underestimating prototype to production. I think this is a really key one that a lot of people do underestimate is, taking your idea and being able to mature it into producing a lot of these things. It's fairly difficult. So the article hits a couple of key elements about the need to stay in prototype as long as you can before and understanding the path to production. Not building an out-of-the-box solution. So always going to a custom solution, which makes sense, or even...
They said building an out-of-the-box solution is bad?
No, they said not building an out-of-the-box solution.
Okay, sorry.
So basically taking a look at every single application as a custom application.
Yeah.
Which, I mean, yes, there's some type of customization, but I guess the point of the article is starting at the core level of every single application from the very beginning to the end is a custom application. And that gets back into the production issue where, your starting point shouldn't be a custom object every single time.
I think that's an excellent point. I think the reading between the lines there is if you're going into production, the word that is hidden in the word production is product.
Right.
And you want to deliver a product, not a service.
That's fair. And, also if you look at the life cycle of it, right? So if I've got an out-of-box solution and if I've got 20 customers, I can support an out-of-box solution easier for those 20 people than 20 different custom applications. So it's a fair look at the industry, but also, there is some need of customization. So it's a balanced approach. Focusing on the technology, not the problem. I think that's a common issue across all industries and all organizations where let's bring in a robot. Well, you don't bring in a robot just to bring in a robot. I mean,
unless you're doing a test bed.
Exactly. Then you define the problem statement of we want to understand the production implementation of a robot. Then you scale down for a test bed and you do something small, right?
Right.
Starting with a technology and then coming up with the problem statement, that's a huge problem. And I think the article hits on that key element pretty well. And the last one, I think it's fair, but at the same time, I am interested about it. Trying to reinvent the wheel. I guess the point of the article was that if a solution already exists, what are you doing differently? Right? Are you providing another wheel? Which is fair. I mean, there are competing products, right? There are subtle nuances between certain products, but it's kind of connected to, not building an out-of-the-box solution and getting things ready for prototype.
Yeah.
There is a lot of connection between all the previous items, and I think it's fair, and it's a very good process approach to how you absorb new technology as opposed to, hey, let's do the thing ourselves, but the thing already exists in the industry. We want to just bring that in and customize it.
You're such a stereotypical engineer. You used one of the expressions I hate the most.
What's that?
Somebody in college once told me that engineers have to be creative. They need to think outside the box. And this person was an engineer.
Yeah.
It's like, if you thought outside the box, you wouldn't use the expression think outside the box. That's one of my most hated expressions. The other one that you used was reinvent the wheel. We shouldn't reinvent the wheel. We should absolutely reinvent the wheel.
Yeah.
The wheel is terribly aerodynamically inefficient. It is an awful means of moving something easily. I mean, it's simple.
Yeah. But again, to get back to what's the problem statement?
Fair enough. Engineers,
man. Awesome, Steve. Where can they find more info about us?
amtonline.org/resources.
Awesome. This is a great episode.
Like, share, subscribe. I'm just kidding. We're not YouTube. Just go there and subscribe.
Thanks, everyone.
Bye, everybody.
Bye.